Hello, and I welcome you all again in this course. Today we are going to move another most important module. This module will definitely furnish the purpose of the course, and in this course and in these lectures we will discuss all the things which we have discussed from the beginning up to the end. So this is our final goal which we need to achieve in order to get the bar bending schedule. In our previous class, what we have done, we just took a foundation and we try to discover the detail inside the bar bending schedule. So what we will do in this particular class is we just get the whole foundation, because for the building you don't have one foundation but you have multiple foundations that need to be carried out. So before moving forward, let me tell you one thing very important, that is if we are talking about the footings or the isolated footing, we have set of footings. Like for example, we have 4 types of footing particularly, or 5 types of footing. So these 5 types is distributed in different areas. For instance, I will tell you an example that if you see, this is one of the foundation, or this is the footing, and this is known as, the name I given to this footing is F1. Okay, so based on what I put the name of this footing is F1 is the size, and what is the detail inside is all having a same. Okay, so if I have the same footing and foundation dimension and rebar details, so I will keep the same name, so that I can use this as a similar when if I get the quantity of this particular foundation, it's mean that the other foundation has same specifications, same sizes, same details. So in this way, if I get the detail of this particular foundation, it's mean how much the foundation I have, we just simply multiply with the numbers, so the quantity we will receive, and this will create much meaningful and easy work for us. Okay, so I will try to search out F1, how many footings there in this particular drawing. So as you can see, F1 is, this is the first, and this is also F1. Okay, so it's mean we have 1 plus 1 2 footings we have. So there is no other footing like F1, so we will say F1 we have 2 footings. So this is the very basic thing for the estimate, that you have to divide the things from the very small to the larger concept. Okay, or alternatively, what you will do, that you will take a larger picture, then you have to divide it into the smaller one, so that you can manage your estimate. Okay, so now we are moving on the practical basis, that how we are going to get the estimate or bar bending schedule of this particular portion of the bar bending schedule. Okay, so as you know, our focus is only on the footings. Okay, so what details we need in order to get the bar bending schedule. So I will bring you to this particular schedule. This particular schedule will always be available with the drawing. Okay, so whenever we have the foundation or any other drawing where we are using the steel, there is a schedule of foundation. So schedule of foundation will help us to know the size, the diameter of the steel which we are using, the spacing between the steel bars, what are the bottom arrangement, what are the top arrangement. We will discuss this all in one by one. So I am going to start this from the beginning. Okay, as you can see, this is the type mean F1, as I discuss this, that F1 means that this is the F1. So all the relevant detail which I need to get the bar bending schedule will present in this particular table. So this will help me to get a better idea. See, this is F1. What it is saying, that this is giving the size of the PCC. This is not relevant for us, but you just need to know that this is the size of the PCC. If you are interested to know, you can study this, but this is not relevant at this stage. So I will discuss about the size of the RCC, that is reinforced cement concrete. So what is the size? 3200 mm, which means 3.2 meters, then 3.2 meters into 0.4. Okay, so this is all about the size of the RCC. Then if I move to the next column, you can see that short steel and long steel. Short steel, I mentioned there are two kind of dimension. One is the linear dimension. If the dimension is longer, it's mean that this is considered as at the longer dimension, and if the dimension is smaller, so it will consider as the shorter span, or you can use it as a main bars. Okay, so in this case, if we see, this is the square, not the rectangle. So if it is square, it's mean the dimension is same. So we don't need to differentiate it as a short steel or long steel. Okay, so it will not create any difference. Okay, as you can see that this detail is very important and relevant in order to get the bar bending schedule. So T means is 14. Okay, 14 means that it's the diameter of the bar which we are going to use at 150 center to center. What it means? Okay, we have discussed this in the previous class, that in this direction we have number 14 bar of steel, and the distance is 150 mm center to center. So it is in the both side. So this is also for F1, F2, F3 and F4. It will be the same. Okay. Now I am telling you that how I can get this bar bending schedule for that particular portion for everyone. So what I will do, I will load the bar bending schedule over here. As you can see, I have marked all the steel bars over here, and here also. I don't need to put steel bar everywhere. Okay, like for example F2. For F2, I just mark over here the steel bar, and what I will do, I will just copy this dimension and put everywhere F2. So it will be same for all. Okay, so this is the very first step that need to be understood. Okay, so what I will do, for example F1, I will draw the this detail and marks which we have discussed in the previous class. If you don't know about this, you can refer to the previous classes. What I will do, wherever F1 is, I will just copy these two dimensions. Okay, when I copy, I will just simply paste over here. Okay, F1. If there is another F1, we will simply keep copy and paste this in that particular portion. Similarly, what we will do for F2, we will draw a steel bar in only one particular foundation or isolated footing. Then we will copy this into the different footings. Okay, like F2 is here, F2 is here, and F2 is here. So wherever is F2, we just simply copy this dimension and paste over there. Then there is F3. The similar thing we will do in this case. Okay, for F4 we will do the same thing. So just divide it into types of foundation, then draw bars in that particular foundation, then mark that one, then copy in the relevant type of the foundation. Okay, so it's mean that all this data will automatically reflect in our bar bending schedule. Okay, so I will delete this for now. So how it works, when I get my bar bending schedule, so I will just select this particular line, bar bending schedule table. Okay, and what I will do, I will just simply keep over there. Okay, as you can see that this already been drawn now. Okay, so if I am saying, so if I want to trace this particular 1 mark, so I will just refer over here. As you can see, this is 1. Okay, and all the details that the dia of the bar is 16, 150 mm center to center, number of bar is 21, length of one bar is this, and E is 3.12 meter that we have linked the bar. Okay, so as you can see that the detail is over here, that 21 into 2, why it is not showing 21? Here it should show 21, but why it is not showing 21? Instead of 21 it is showing 42. So we will see over here that we have two foundation. Okay, when we copy this particular mark in this foundation, so it automatically understand the software that this same detail is present in two particular areas or the footings. So it will definitely reflect all the same detail over here. So it will be 21 into 2. So it will do the same for all. So in this way you can do your job very easy and quickly. So this is all for this class. Okay, so if you have any query or question regarding this, you can simply ask and I will definitely reply you accordingly. Okay, thank you so much.